Welcome back to the Old Iron Lover channel. My name is Bob, and today we're going to build a special tool. I got a request from a friend to help repair their washing machine, and it has the tub bearings are on the outer tub for the actual wash tub are shot, and it's a front loader, so the tub, when they're in the spin cycle, bangs around inside of the inner tub bangs around inside of the outer tub. So looking at what was required, it's going to take some special tools to pull the bearings. Get a little closer look at what's going on here. So in this washing machine, the inner tub is the one that spins, and it has a shaft sticking out the back of it. The outer tub has a housing that holds an inner and an outer bearing. It's an inner and an outer bearing. And the shaft comes through. There's a nut and a washer and a pulley and everything on the back side. Take a piece of 3/4 inch rod, thread it the length, whatever length I choose, and on one end I'm going to cut down the shaft and thread it with a left-handed 1/2 inch thread. And then I'm going to have some discs that go on here that match up to the inner diameter of this, the inner diameter of that, and the outer diameter. There are 2 of them. These will be the things that pull the disc out. On the bigger threaded end, there'll be a big cup going to be made out of this steel here. And I'll just slice off a piece of it, weld a plate on the top, and put a nut on it. And that'll be a 3/4 inch fine thread, right threaded rod. And that cup will go on, and it will cup over these bearings and push against the outer tub. And when you tighten the thing up, it'll pull out this way, which will tend to pull it the plate or whatever you have on the back side of it, and it will not loosen this up because it'll be a left thread, so it'll tend to pull it in tight too. There'll be a plug there's a spacer that sits between these two, and there'll be a plug that goes through the outer one and seats inside the inner one. So we put the inner bearing in, we put the plug in, we put the spacer on the outside of it, and we put the big bearing in, and when the big bearing is seated tight, it will hold that sleeve in place. Then we can push the temporary plug back out. I'll make that out of a piece of aluminum. So anyway, that's the general idea. Got to be all lathe work. We're going to start out by making the shaft. Okay, the first thing we're going to do is face off the end, and then put a little center drill on the back side of it, so when we get this thing strung way out here to thread it, we won't have we'll have something to support the back end on the tailstock. Three-quarter inch fine thread. Fine thread actually probably is a little better than coarse thread for what I want to do, but the main reason I have a 3/4 inch fine thread is that I don't have, in my coarse threads, I only go up to 5/8. Okay, I believe when I last left off, I was in the process of making this this die stock here, and it came out real well. I mean, the brazing, I could polish that up, but basically it works great. I had a 2-inch die and I had no die stock. I thought I had at one time a die stock for every size of die that I had, but that one must have shown up out of the blue. Anyway, the back side of it is opened up enough that we clear all the chip breaker areas there. So I used that in my lathe, put a piece of 3/4 inch stock in the lathe, and had a center hole in it to hold everything in place. And I got this started and just let the handle rest against the saddle and followed it till it got all this done. Put a this is a 3/4 inch fine thread, put a 3/4 inch nut on it, cleaned all the chrome off of it, and welded that in place. Then I went back and turned a couple of inches off of the end of it and put a left hand thread, a 1/2 inch thread on it, and made a little left hand nut for it. So if you kind of picture it this way, here's the cup, and there's the bearing I'm going to pull out. I'll get everything arranged like that. I'll put the disc that fits this bearing, a washer, and then I'll just hand tight this on. Okay, now the reason for the left hand thread. As I turn this counterclockwise, it's going to force this piece in and this piece up, so it's going to bring them together. And this I don't really anticipate moving, it's just going to keep it from unscrewing itself. And as I go on this one here, it's going to force it in until it seats against the housing, and then a little bit more and it's going to pull the bearing out. Anyway, hope you can visualize that. I'll show you again when I get it all done, but just wanted to show you the progress I'd made at this point, which was to make this piece up here. Okay, we're going to set that aside and get some stuff set up, and we'll come back to you in a bit here. We're going to cut a plate to fit the back of this, and going to do some welding and threading on it. So thought I'd take just a quick second here to show you a little trick I kind of came up with. It's not exactly even here. I should have gotten those blocks across from each other. I'm trying to make a shorter work out of turning a square piece into a round piece. So I put them in the V blocks and lopped off the opposite corners. Now I can turn them and cut the remaining corners off, so I'll have more or less an octagon. Whoops. I should have gotten these two even with each other, and I'd have got, you know, a more square cut, but it's not going to really matter. It's just getting rid of material. So anyway, might be a handy trick for you sometime. I got a hole drilled in our piece of plate, and I have a poor man's 5/8 inch mandrel in there, and we're going to start turning it down. I'm going to bring my little ring over there for size, just to be sure I get it right where I want it. Ultimately, I'm going to wind up welding the two pieces together, threading the inside of this and a nut on the back of it, and make my little puller piece. So going to ease into this for a couple of reasons. One is that I don't want to chip up my insert with the seriously interrupted cut. And the other is I don't want to unwind the screw on the nut on the back of the mandrel. Now I put that on there tight, but it's, you know, how tight is tight when you start banging on it. So sneak up on it here and touch off. Okay, we're down to probably the last cut or maybe two here. And I'm still taking 10 thousandths at a time. I think should be down to one flat spot left. Yeah, that's not much. Okay, so I'm going to hold it right even with the bottom there, and we are even there. I think it's time to quit. This is going to be a weld joint anyway, so it's not going to be pretty when it's all done and zed down, unless I come back in and turn it again. So let's dress off the nasty edges. I think to make welding on it just a little easier, I'm going to turn just a little bit of a lip here so I can set it in there. Yeah, not going to be much. Probably less than 1/8 of an inch. Put a travel dial on there so I get the same place each time. Okay, and I don't know how far in I'll have to go. I'm going to go dress up the inside of this ring real quick, so the weld joint in there, and I'll come back. Okay, got the mandrel cut off. Needless to say, when it spun in the chuck a few times there, it boogered up the thread. So I just cut the bolt in two and threw it away, and got this dialed in, within a few thousandths here, given the mill scale and welding boogers and whatever else on there. So anyway, I'm going to take a little facing cut on there and kind of clean that up. Not that it needs to be flat for any particular reason, other than I want to be able to weld to it nicely, and it needs to be clean. So this is really a cleaning operation rather than a facing operation. And since I have just a little bit of surface area there to grip on the outer perimeter, I'm going to take whatever cuts I take are going to be pretty light. I think we're taking maybe a 10,000th cut. That's it. That's really all we need. I could come in from the other side, I guess, and trim that side off a little bit. Now there's nothing holding that one. Okay, now the last operation on this is going to be to chuck it up and up against the face, and actually bore it with a boring bar to get the diameter we need for the tap. Okay, now let's take a quick measurement. And we want to be at 688. Okay, we should be about 5/8 of an inch right at the moment. $626. I said 688, so I need to be 42 more. So touch off and take a 20 and see what we got. This also makes it concentric with the outside. We're shooting for 688. It doesn't get any closer than that. Next operation is to thread that. Then I'm going to run the nut. I'm going to run a bolt in there, run the nut up on the bolt against this so it's all together. And then I'll weld around the outside of the nut, and then I'll have threads the thickness of this plus a nut. Oh, back gear dropped out. Hands are clear. Okay, the first piece we're going to build is a little slug that goes in between, goes into the small end bearing and through the sleeve here. And it'll hold the this piece in place radially until we can push the big end bearing in and get it pressed up against this, and that'll hold it in place. And then in the final analysis, the shaft will go through there and it'll be fine. But in the meantime, you need something to hold it while you're putting that other bearing in. So we're going to turn this end down to my little mark here. The diameter of the big bearing, the inner diameter of the big bearing or the sleeve, and then we're going to flip it around and we're going to turn the other end, the diameter of the small bearing, so we can slide it into the small bearing and it'll hold the spacer out where it needs to be. So anyway, we've got a lot to turn off here. We got to get that down to that. So we're going to be spinning this lathe a bit. All right, so I'm going to touch off and see what kind of cuts I can take. Okay, we're down to the last pass. We need to take about 15 thousandths more off. Very nice. I'm going to Okay, we got the big end done, and now we're going to turn the little end down, and it needs to be at 1/180, something like that. We'll fit it to the bearing when we get there. Close to our final dimension here. Taking a few thousandths, quarter of 2 thousandths, something like that. Yeah, that fits on there. Not. The only thing left now to do is to make some of the pusher plates that go on to the that basically pull the bearings or push the bearings into place. And this piece of steel turns out to be, the OD of that seems to be the outside of this inner race. So that's going to make a real good pusher there. So I need to face it off, put a little lip in it so it'll come inside the bearing, and drill a 1/2 inch hole through it and cut it off to some random length. Okay, we're making the next one 180 total OD, and then we'll cut a little lip on that. Good fit right there. Well, thanks for watching, and I hope you enjoyed the video. And if you enjoyed it, give me a thumbs up. If you feel like subscribing, that's always welcome. And until we get another video ready for you, happy trails.